Welcome to chapter 13 on electric fields. This chapter is very similar to gravitational field. Still remember gravitational force? Gravitational force is G mm over R square, right? This gravitational constant, 6.67 times 10 power minus 11. This is the big M, this is a small m. They're separated by distance r, and there's always attractive force. These two forces must be always equal magnitude, opposite in direction, because they are a pair of action-reaction. What about electric force? Electric force is very similar to gravitational force. Electric force is QQ over r squared as well. See, it's similar, but this one has the constant here is 1 over 4 pi epsilon naught. What is epsilon naught? Epsilon naught is called the permittivity of free space in vacuum, or free space, which is free space means vacuum, okay? 5 times 10 power minus 12. Well, this will be given in your data booklet. You just sub inside here and get the number. Please do not use this whole number as 8.99 times 10 power 9. This is what is taught in some of the JC, but actually this one creates a lot of truncation errors. Actually, the final answer is not 8.99, it's 8.9x something a lot. So you shouldn't use this number at all. Please remember that. Just sub 8.85 times 10 power minus 12 in this number epsilon naught and do your calculation. By the way, if you do not know what I'm saying, this is epsilon naught. This is how we read this funny symbol. This is a charge. This is a charge. If you have a positive charge and a positive charge, they will repel, okay? If you have a positive charge and a negative charge, they will attract. See the difference? For the gravitational force, is only attraction. For the electric force, there will be attraction and repulsion. Depends on the type of charges. This is one of the difference, okay? Now, M is analogy to big Q. Small m, analogy to small q. R and R the same thing. You see, they are analogy. They are almost equivalent. So what is the importance about this formula? This is actually Coulomb's law of electrostatic. It says that the electric force is directly proportional to the product of the 2-point charges. See, this one is actually proportional to QQ over R square, right? Why R square? Because this is a constant. So that's why we can say is directly proportional to the product of the 2-point charges. Remember, all these are point charges. They are not a sphere or something funny shape. Okay, so this is a definition. You must put the word point charges. If you miss out the point, this word, your marks will be deducted. Okay, this will be a 2 marks definition question. And inversely proportional to the square of the separation. This is common stuff, right? Like the G field. Okay, I need you to remember this. Now, let's see what is the effect of this force due to the value here. For example, let's say I ask you a simple question. Let's say this force is 10 Newton. This force is also 10 Newton. And this is 2 Coulomb. This is a 1 Coulomb. Alright, what happens if I change this? Okay, and this distance is a 3 meters, let's say. What happens if I change this 2 Coulomb to 4 Coulomb? What happens to the force value? Look, it's very simple. F proportional to QQ over R square, right? Now, just now was 2 times 1. The product is 2. Now, it's 4 times 1. The product is 4. So, obviously, this number has doubled. So, the force also will be doubled. So, this one become 20 Newton already. This doubled the force. What if the distance now increased to 6 meter? Well, when the distance increases to 2 times, the 3 to 6 is 2 times, right? Increase 2 times. The force will decrease 4 times. So 20 divided by 4 is just 5 Newton. I hope you can feel the thing. I hope you can feel the importance of the product. If it is double, force is double. When the R is double, the force will be quartered. Do not worry about this permittivity of free space. Usually in an exam, you will just deal with this. Only very rare cases, they will deal with another value called the relative permittivity, which is not in vacuum. So in other words, you see, this gravitational constant, this number is applicable everywhere in the space, be it these two masses in the outer space or on Earth or in the water. The number doesn't change, but this is not the same. This epsilon naught will change according to the medium surrounding it. Just imagine if the epsilon naught drop, the F will increase. You understand? Now, so in this case, what I'm trying to tell is the surrounding medium affects this number. Okay, so you need to but most of the time they will give you free space, otherwise it's become very complicated. Okay, so you do not worry about this. Just use this number 8.85 times 10 power minus 12. But what I want you to understand is that different medium will affect the force value. Okay, it's not the same as gravitational force. Different medium, it doesn't affect the force value. Next, let's take a look at how do we calculate the force between multiple charges. Let's say this is 4 meters, this is 7 meters. This one, let's say this is 90 degrees. Okay, so what is the force acting on this charge? So what you should do, instantly you should calculate what is the force acting on this charge due to this and this separately. So due to this and this, there will be attractive force acting by the positive charge, right? Let's say it's called this F1. This one will cause repulsion, right? So remember, this is still 9. Let's say this is F2. Let's calculate F1. What is F1? F1 is QQ over 4 pi epsilon naught R square. You must understand, force is a vector. You must solve it vectorially, okay? So Q is what? Let's say this is a proton. Proton is 1.6 times 10 power minus 19. This one, let's say this is electron. Use also 1.6 times 10 power minus 19 divided by 4 pi epsilon naught is 8.85 times 10 power minus 12 R square. R square is 4 square. You get some number. You do the same for F2. R change to 7 square. This is QQ, right? So you get F1 and F2 already. What you should do? You solve it vectorially. This one and this one is a Pythagoras theorem. You get this one, right? Correct now. So the F net square root of F1 square plus F2 square. That is the answer. Okay, just dump all the final answer inside. Alright.